Cool.
Hello everyone, I'm Michael Ford and I was the Group 3 reporter for the bomb cutover experiment. So just to go over what we did and everything with it, our objectives were to become familiar with the physical principles and everything involving the bomb calorimeter. And we wanted to find primarily two things, was our thermal capacitance of the calorimeter and the gross heat of combustion of our samples that we used. And so we used the first law of thermodynamics, Q equals mc v delta T, where Q was our heat of combustion of the fuel sample and the ignition wire. Our thermal capacitance of the calorimeter was the mc v, which basically tells us how much heat was stored in the process, and our delta T was our temperature rise for each experiment. So the apparatus, again, this was the bomb calorimeter, overall with the bucket and everything. Basically, we placed our stainless steel bomb inside a bucket that was filled with water, and a thermocouple was used to read our temperature rise of the water. And so the bomb lid inside it had a crucible which held our fuel sample, which was ignited by our ignition wires and two electrodes, and this was all contained inside stainless steel. So our procedure, I condensed it down a bit and used what exactly we used. We first cut 10 centimeters of chrome ignition wire, and then we measured 1 gram of benzoic acid, and we placed that into the crucible. The experiment was repeated with Sour Jacks, which was our unknown fuel sample. We did use 1.06 grams of Sour Jacks in the second experiment. So we connected our ignition wire and we put a milliliter of distilled water into the bottom of the bomb by dipping your fingers in and flicking it in there. And then everything was tightened and the air was purged by alternating the pressure from 1530 ATM. This was to make it pure oxygen so we could combust it. And it was left at 30 ATM the final time. So we added water into the bucket to this line inside the bucket, which is approximately 2 kilograms according to the lab manual. And we positioned everything inside the calorimeter jacket where we wanted to make sure that it was all positioned properly. So our thermocouple had to be submerged in the water and without contact with the bomb or the bucket. And then a rubber band was placed on in the motor pulley and the stirrer pulley and then turned on. So we recorded data for approximately 3.5 minutes. The first 30 seconds was with room temperature before fuel was ignited, and we'll be able to see this in the data results. We stopped whenever the temperature stabilized for the experiment. We stopped recording data whenever the temperature stabilized, and we turned everything off, disconnected the bomb, and we measured the remaining ignition wire that was left from the experiment, and then we repeated with the Sour Jack fuel sample. So here we can see our temperature rise of the water during the experiment. So the first one we did was benzoic acid, which would explain why it was starting off at a lower temperature. There is a small dip in the data, but that can be, it's so minimal of temperature difference that the air can't really be determined what it came from. But we can see that it went from around 21.5 to 23.5, and compared to the Sour Jacks, the temperature difference is much smaller. Well, not much smaller, but it was smaller, and this went from 24 to 25.4 degrees Celsius. So we wanted to calculate our heat of combustion of the Sour Jack, but we needed our thermal capacitance of the overall system. So we did this by using Q over delta T, and you can get the Q from the benzoic acid that was on the bottle. So you had that, and then we measured our ignition wire, and it came out to 7 calories left. And so you start off with 23 calories, so you use 16 calories in the process. So adding that and the benzoic acid together, we had our total heat of combustion, which was converted to kilojoules, which helped us find our thermal capacitance. This number was then used for the Sour Jack sample, but that would give us the total heat of combustion. We wanted to know just the thermal the heat of combustion of the sour jack. So you had to subtract the ignition wire energy used, which was 4 calories, to get your heat of combustion of the sour jack. And so when we compare everything, we have our delta T of the benzoic acid was higher than sour jacks. As a result, to use the same numbers, the heat of combustion was higher. That was measured all with 1 gram for everything besides the sour jacks, although it was very close to 1 gram. When you compare this to gasoline and dry firewood, you can see actually that sour jacks, according to our experiment, is similar to dry firewood, but gasoline has a much higher heat combustion value. And so, in conclusion, from this experiment, we can find the heating value for a fuel, and benzoic acid has a larger heat of combustion value compared to our sour jacks. Sources of error could have came from approximations using experiments, with like how we measured things, improper placement of components that shifted around, instrumentation error, human error, and according to how the experiment went, you can actually find other thermodynamic properties with this experiment, but that we did not focus on, such as like your late heat of vaporization. So, yeah, any questions?